focused on a KB for a healthcare service. In the previous video, we saw all the rules, events, and checks that were performed when trying to insert data in a two-level transaction and through the business component. Here, we'll look at update and delete. We'll want to change an office visit. Since the date, physician, and shift are part of the primary key, none of these attributes can be modified for an existing record. We can only modify the office because the last number is used for the serial rule, so it cannot be changed. The patient entered in a line cannot be changed either because it's part of the primary key. Only the secondary attribute corresponding to the number given to the patient to receive care could be changed, except for the fact that we placed a no except rule for that attribute. We can comment it to have an updatable attribute for each line. Let's comment both the serial rule and the no except rule, so we can also modify the header attribute, the one for the last given line number. Of course, we can also add and delete lines to the office visit. Okay, so we want to be able to change the office of a given office visit, change the number assigned to a scheduled patient, add another patient with their corresponding number, and delete one. Let's start with this. Update Thursday's office visit, changing the office to 3, and adding patient 3. If we do it through the transaction, first we have to locate the record to be updated by clicking here. The transaction is called by passing the primary key and the update mode as parameters. In this way, the record of that primary key is searched for in the header table, and its information is retrieved. The same is done for all the related records in the second level table, and their values are retrieved. We see that the Office ID field is the first editable field. None of the previous ones can be modified. We change it to 3. Of course, if there were another office visit for that day on that shift in that office, here we would get an error stating that this candidate key already exists. This is not the case. Let's change the number given to the first patient to 2, add patient 3 with number 3, and also change the last number to 3. After confirming, the operation performed will be an update of everything. Even if at the lines level, this means changing one line and adding another. Now we'll want to work in this way, but through the business component. Let's suppose that, in addition to changing the office, we want to change patient 3 for patient 4. Since we can't do it directly in the record because it's part of the primary key and it cannot be updated, we'll have to delete the record and insert a new one with the correct patient, and the same number that patient 3 had. We've added 2 more variables for the patient we want to replace with the other one for the office visit with that date, physician, and shift. We'll add an event to update the office visit of this primary key. First, we have to load the data corresponding to the primary key in the BC variable. The operation will only be successful if there's a record in office visit with that key. We can check it with the success method, or its opposite, fail. We'll display messages on the screen indicating whether the record we tried to load exists. We'll also retrieve the messages in the message collection. Let's try it quickly. We know that this record, the one from Thursday, exists. So we try its key, and it was found. And now we enter a date for which there are no office visits. We see this other one. The success method was false. and the message collection shows an error indicating that the primary key was not found. Let's remove this check, because it'll be done anyway when we do the update. Next, we modify the office visit according to the screen variable. We add 1 to the last number given, because it's the one we'll use to change the number of the first patient, the one in this variable. To do so, remember that we have to use a variable of the BC data type of each line. And use the Getby Key method of the patient collection of the BC that we loaded here. We have to send the line ID to the method so that it can return a reference to that item in the collection. It'll be a reference to the item itself, to its memory location. It will not be a copy. Therefore, it'll be enough to modify the value of this element for this variable, because it'll be modifying the item of the collection directly. There's no need to do any update. This is enough. Now we want to delete the line corresponding to this patient, to insert another one, and change the patient. But before deleting it, we need to retrieve the number that was assigned to it. To do so, we assign what's shown on the right to a variable where we'll store that value. Here we're retrieving a reference to the BC of the lines that have this value in the identifier. And from that BC, we're asking for the patient number. And now we can delete the line. To do so, on the list of patients for an office visit, we run the removeByKey method, to which we send the identifier of the line that we want to delete, which is the ID of this patient, that of the second variable of the web panel screen. For now, this method only deleted the item from the collection in memory. We have not done anything in the database yet. Lastly, we must add a new item to the collection for the substitute patient, with the number given to the patient being replaced. We still need to insert this item to the collection. We do it with the add method. In this case, it was essential to ask for new memory for this BC variable of the line because we had already used it here. If we didn't ask for new memory, then we would be inserting to the collection the same location in memory that was already there. So instead of 2 lines, one for patient ID and another for patient 3 ID, we would only have 1, with these values that will have overwritten the first ones. At this point, we've already made all the changes we wanted on the BC variable that we loaded from the database. Now we need to ask for what we would ask in the transaction by pressing the Confirm button. That is to say, to update the information in the database, running all the business component checks. If the result of the update is successful, we commit. And in any case, we retrieve the messages that are generated. Let's try this. For this office visit, we want to change the office to 2, give patient 2 the number following the last one, and update the last one, delete patient 3, and add patient 4 with their number. So here we choose these values, those of that primary key. Office 2, patient 2, 3 that we want to change to 4, success, as expected. Now, let's cause the update to fail to confirm that it's checking everything that we would expect it to check. For example, Let's try to change the office to 3. No problem. Give patient 2 the number following the last one. No problem. And delete patient 4. No problem. To insert a new line for patient 1, who we know is already scheduled for an office visit involving this specialty. Since the line will be inserted, the transaction error rule that prevents the database from being updated should be executed. Let's try it. It was indeed triggered, and the office visit remained unchanged. No update was made to the database. If we now choose to give the last number to a patient who's not included in the office visit, for example, 1, who's not there, and we change 4 to 3, which shouldn't cause any problems, that is, we change the office to 3, choose patient 1 to change their number, and change 4 to 3. Why would it let us update successfully if patient 1 does not exist in the office visit? Let's look at the code. The problem is that Getby Key did not find an item for patient 1 in the line collection. So this variable will not be able to update the line because it won't be pointing anywhere. The other operations did not find any problems. If now, to update the first patient, we give that of an existing line, for which we also want to delete, but we make a mistake with the new one and choose one that does not exist. In this way, for example, we ask to give the last number to patient 3. Delete patient 2 and replace it with 25, changing the office to 2, for example. Well, we get the referential integrity error of the patient. What if we made a mistake the other way around, with the one we want to delete? And it allowed us to update. Why? Let's see what we did. It increased the last number by 1, good. Assigned it to patient 3, good. But left patient 2 as it was, and added 4, with 0 for the number. Let's see it in Genexus. This will give us 0, because it won't find the item with key 25 in the collection. And this remove operation will not remove the line for this key because it does not exist. So the new will be performed successfully, but with value 0. We can improve things a bit, asking for the result of the remove operation, and add the line only if it was successful. Last notes. Here we have the office visit on Thursday 17 for physician 1 on shift 1 in office 2. Let's add an office visit with another physician for the same date and shift, but in office 3. If now we want to change the first office visit, that of physician 1, to office 3, which is now busy, the update will fail due to a duplicate candidate key. And if we want to change the office to a non-existent one, the referential integrity check will fail. And of course, if there's no record with this primary key, no matter what values we enter in these variables, when we try to update, we'll get this error, because the load was not successful. In summary, to update through the transaction, the value of the primary key is sent to it, and there, the values of the header and line attributes are brought from the database to the screen. To do it through the BC, the load method is applied to load the elements of the BC structure. So the attributes on the screen and the lines are like the elements of the BC and the items of the collection. The user can change those attributes of the header that can be modified, and the developer does the same with the BC through the variable by accessing this element. BC variable, period, element name, for example, office ID. In the transaction, the user can change some data of a line directly by clicking on that line and editing the desired field. To do this with the BC, you must first access the line by code, that is, the item in the collection. To do so, there's the Getby Key method that can only be applied to the BC element that's a collection of lines. Here, it's office visit, period, patient. Unlike the transaction, where we can see the line and its values, here we have to retrieve it, starting from its identifier. If there's an item with that ID in the collection, then we'll perfectly retrieve the memory location of the item. And it'll be convenient, surely, to assign it to a variable of the BC data type of the line to work more comfortably. There, we modify the elements of the item/line that we're interested in. It could be the patient office visit number. But what if the ID that we specify for the Getby key does not exist? The office visit patient variable will not be pointing to the position of the line. If it had not been used before, or had been assigned a new, then it will be empty, and the change made to the patient office visit number will have no effect on the original BC. If we want to remove a line from the transaction, we identify it and mark it like this. In the BC, we have the remove by key method of the items collection. Again, if we pass an item ID that's not in the collection, it will not be able to do anything on that line that we wanted to delete. Everything will remain unchanged. This method has the advantage of returning true or false based on whether it finds the item. And if we want to add a new line to the transaction, we do it directly using one of the empty lines provided by the grid. In the BC, we'll have to create the memory space for the item with a variable of the data type of the lines. Also, by assigning it the new, complete its elements, and use the add method of the collection of items. That's how we add this memory space to the collection. So far, either by handling the transaction or the BC variable, we've worked in memory. For all this to impact on the database, the order must be given. In the transaction, it's done with the confirm button. Since it's in update mode, it'll try to update. In the BC, we do it with the update method. We could also use the save method, but we're not going to see it here. As a result, the corresponding rules, events, and transaction checks will be executed. That is, in the BC, all those that do not depend on the interface and are not qualified to run only on the web through the environment attributes that we had seen in the previous video. In short, when working with the BC, we have to be more careful because we don't see the existing lines, and we can make mistakes in this programming. Then we'll discuss a simpler way to insert or modify lines, but not to delete them, which is to handle them through a data provider. Lastly, we want to delete, so we add the button, and in the associated event, first we load the BC variable by primary key. The three variables are displayed here. And then we apply the delete method to the BC. For now, this method does not return true or false as the insert and update do. So to know the result of the operation, we'll have to execute the success method, or its opposite, fail. Let's first test the deletion of an office visit that we know exists. This one. We enter the key values. And it deleted without any problems. If from another table, there were a record referencing the one we wanted to delete, then the deletion would have failed due to referential integrity. But this is not the case. In our application, at the moment there's no subordinate table to this one, that is to say, that references it. And if we now enter a non-existent office date, it throws us this error that's not very clear because it mentions an update, but actually The get indicates that it failed because it could not perform the load. We could try the delete only if the load was successful. Of course, it could happen that the load is successful, because the record exists, but the delete fails, for example, because of referential integrity, as we've just said. Or because there's an error rule condition to be triggered on delete, and with another condition that's met. We've now finished reviewing the relationship between updating through the transaction and updating by code through the business component, with examples of the three modes.